Hi everyone, in today's lesson we'll be taking a look at rectangles, rhombuses, and squares, and they're also known as our special parallelograms or special quadrilaterals. Our first one is a rectangle. A rectangle is defined as a parallelogram with 4 right angles. And we should be familiar with what a rectangle looks like. So to start with, we have to know or be able to prove that it's a parallelogram. So let's just mark in those sides as being parallel. Both pairs of opposite sides are parallel, so it is a parallelogram. And if each of these angles is a right angle, then we know that we have a rectangle. Okay, so again, a rectangle is a specific type of parallelogram, and what makes it a rectangle is the fact that it has 4 right angles. Our next special quadrilateral is a rhombus. A rhombus is defined as a parallelogram with 4 congruent sides. So, for example, if you had a little parallelogram, and again, we'd either have to know, like be told that it's a parallelogram, or we have to be able to prove that it's a parallelogram. But then, if all 4 of these sides are marked congruent, then we know that it's a rhombus. So let's say the sides are each 4 units long. Then we have what's called a rhombus. Again, it must be a parallelogram first, but then if all 4 sides are congruent, we can determine that it's a rhombus. Okay, if you take all the characteristics of a rectangle and you combine it with all the characteristics of a rhombus, you get a square. A square is a parallelogram with 4 right angles and 4 congruent sides. And we all know what a square looks like. So again, it must be a parallelogram. And more specific than that, it's a parallelogram with 4 congruent sides and 4 90-degree angles. Next, we're going to take a look at some specific theorems related to rectangles and rhombuses. The first one talks about the diagonals of a rectangle. So sketch a rectangle in the space that you've got, and let's call this rectangle A, B, C, D. Okay, since we're told that it's a rectangle, we know it's a parallelogram, and because it's a rectangle, we do have 4 right angles. Now, what's true about a rectangle, when you draw on these diagonals, if you take a look at them, you notice that they look like they're congruent, and that's what our first theorem states. The diagonals of a rectangle are congruent. Now keep in mind, this is not true for all parallelograms. If you draw another parallelogram, but don't make those angles 90 degrees, can you see how that diagonal is definitely shorter than this huge long one? Okay, so only in a rectangle are the diagonals congruent. Our next theorem deals with a rhombus. So if you could sketch a rhombus. So remember that a rhombus is a parallelogram of 4 congruent sides. And this theorem states very simply that the diagonals of a rhombus are perpendicular. So they're going to intersect at a right angle. Now notice, if those diagonals, since they're perpendicular to each other, and let's put some points in here. Let's call this A, B, C, and D. So we would know that line segment AC is perpendicular to line segment BD. That means that we've got these 4 little right triangles that we could work with. So we could use the Pythagorean theorem to solve for a missing side in any of those 4 little triangles. In addition to being perpendicular to each other, the diagonals of a rhombus do something else. So again, if you draw a rhombus, just do your best to sketch it. It's not exactly right, but if we draw on those diagonals, we know that they're perpendicular to each other from the last theorem. But what else is true about them is that each diagonal bisects 2 angles. So this diagonal from B to D would bisect angle B and angle D. And this other diagonal from A to C would also bisect two angles. Okay, finally, our last theorem states if an angle of a parallelogram is a right angle, then the parallelogram is a rectangle. And here's how this works. Let's say we start with a figure that we know to be a parallelogram. Mark both pairs of opposite sides parallel. Okay, if one of these angles is a right angle, since we know that it's a parallelogram, the opposite angle would have to be congruent. So now we have two right angles. The other thing we know about parallelograms is that consecutive interior angles are supplementary, so that would force the remaining two angles to be right angles. Therefore, it's a rectangle. Finally, for today, we're going to take a look at a little flow chart. Okay. So if we start at the top, in general, any four-sided figure is called a quadrilateral. If we take and make the opposite sides parallel, it becomes a more specific type of quadrilateral. It becomes a parallelogram. So a quadrilateral is just any four-sided figure, like that. Parallelogram, we know that both pairs of opposite sides are parallel. Now, from parallelogram, we can make two specific types of parallelograms. We can go in the direction of a rectangle, or we can go in the direction of a rhombus. So if a shape is a rhombus, then it has to be a parallelogram. Finally, if you take all the characteristics of a rectangle and combine it with the characteristics of a rhombus, you create a square. So a square is always a rectangle. It's also always a rhombus. A square is also always a parallelogram. But if you go in the other direction, starting at the top and working your way down, a parallelogram is sometimes a rectangle, but it doesn't have to be. A parallelogram is sometimes a square, but not always. Okay, use this chart when you're answering questions on the CYU and the homework. Good luck on both of those things, and please make sure that you speak up when you have questions.